Hi everyone, I'm Michael Hall. I'm the Community Manager here at InfluxData. And today I'm going to take you to becoming an InfluxDB Pro in just 20 minutes. Now, as Community Manager, I'm part of the Developer Relations team. And our team does a lot of talking with the community, helping people learn our software products and finding out where things kind of struggle for them. So we took all of that information and we boiled it down to 20 minutes of things that you need to know in order to become an InfluxDB Pro. In this talk, we're going to cover 5 main topics. The first one is just how you're going to end up working with InfluxDB, because there's more than one way to do it. We're also going to look at your data schema and talk about ways that you can build that so that it's going to be successful and be able to grow with you and not cause you any issues. Then we're going to take a real quick look at the Flux language and some of the things that people tend to struggle with when they first start learning that. Then we're going to talk about what you can do with your data once it's in InfluxDB. And finally, we're going to talk about getting it out of the edge and up into the cloud. Like I said, there's many ways that you can interact with InfluxDB, but the most common one, the one that most people go to first, is our graphical user interface. This is what you get when you first set up InfluxDB. Whether you're using our InfluxDB Cloud product or you're using our open source version, you're going to see the same graphical interface. And in here, you can perform all of your administrative functions. You can create other organizations and buckets and measurements and tasks. Anything that you can do in InfluxDB, you can do in the GUI, including creating visualizations like this one. But we also have a really powerful command line interface. And this CLI can let you do everything that you do in the GUI, including all of those administrative tasks that I mentioned. It also has this really nice feature where you can have multiple accounts configured in the CLI. So if you have multiple instances of InfluxDB, typically you might have like a local development one, you might have a testing or staging environment, and then you've got your production environment. So you can create separate accounts in the CLI for all of those, really easily switch back and forth between them. And that way you don't have to pass that authentication token and everything every time you make a command. You can just switch to the account you want and run the command. This is also really useful for bulk loading data. If you have a bunch of data in a CSV file that you want to get into your database, the command line makes that really easy to load in. And if you're a developer, chances are you're going to be writing an application that interfaces with InfluxDB. And we've got more than a dozen different programming language client libraries that make that easy. And the best part is every one of these libraries is idiomatic to that programming language. So if you're a Python programmer and you're writing a Python app, our Python client library is going to feel like it was made for that. It's not going to feel foreign or strange or anything. It's going to feel like Python for you. And these libraries also have a lot of built-in best practices. So things like buffering data, being able to recover from network outages, things like that, all done for you behind the scenes so that you don't have to worry about that as a programmer. We also have this really cool Flux extension for Visual Studio Code. Not only does it give you language highlighting and auto-completion like you would expect from a language extension, it also lets you connect to InfluxDB instances so that you can do things like browse your data, see what buckets are there, what measurements, what fields are available to you. You can even execute queries directly from the editor itself, and you'll get another tab with the results of that query in a table. So as you're developing your program, you can actually see what data it is that you're going to be working with and write your program accordingly. You can even use this extension to load and save tasks. So if you need to go and edit one of your tasks that's running in your server, you don't have to go to that GUI or the command line. You can just stay within your code editor, open it right up there, get all the advantage of the Flux auto-completion while you're writing it, execute it, make sure it's doing what you want, and save it right back to the server. So you never have to leave your programming environment. All right, now I want to talk about data schemas, because this is a common place that people tend to struggle. A schema is really just a way of saying, this is what your data is shaped like. This is the kind of measurements and fields that you have and what data types those are. And the schema affects how your data is going to be stored on disk by InfluxDB, and that in turn is going to affect your performance in querying and in writing data. There are 4 main aspects to a schema in InfluxDB. The first one is your measurement. And a measurement is just a way for you to organize your data. Any data that's similar to each other or logically the same, you're going to want to put into the same measurement. That's going to make querying that easier later on. Then you can apply tags to this data, and tags let you distinguish similar data from each other based on things like where it's coming from or what type of data that it might be. Then you can have one or more fields. So in our example here, we're using stocks. We might have a field for the current price, Then we might have another field for a future price, and you can have those all in the same measurement. And lastly, you've got the timestamp. Because we are time series data, everything has a timestamp on it. And that combination of timestamp, measurement, and tags is guaranteed to be unique within InfluxDB. Now, cardinality is a big topic in InfluxDB and time series databases. Every one of those measurements and tag values that you have is going to be indexed by the database to make querying for them faster. But each of those indexes is going to make your data a little bit more complex on disk. And we call that complexity cardinality. And cardinality is basically just the combination of how many measurements you have, how many tags you have, and how many values for those tags you have. And like I said, each one of those combinations is going to have its own spot on disk. And the more you have, the more you're going to start running into some kind of performance issues. So here are some tips for managing your cardinality. First of all, use a measurement name that reflects the category of your data. So things like atmospheric data or a specific factory that you're monitoring. What you don't want is a measurement name that's too specific, like the name of a specific device or air temperature, where you're only going to collect temperature and no other fields. The next thing you want to do is limit the number of measurements you have per bucket. Remember that you can have as many buckets as you want, and you can cross-query between those buckets in your Flux scripts. So you don't need to have all of the data in the same bucket all of the time. By separating that out, you can manage your cardinality a little bit better. When you're creating tags, only use them for things that you're going to be querying for regularly. Like I said, the benefit of tags is that they're indexed, and it makes the queries faster. But if you're not planning on searching by a specific tag value, then it's probably better left as a field. Another thing to consider with tags is to avoid duplicating data. Something that we see often is you might have like a country name as a tag and also a country shortcode as a tag. Now those are basically the same information as far as you're concerned, but as far as the database is concerned, they're completely separate values and they're going to increase your cardinality for no benefit to yourself. And lastly, avoid unbounded tag values. Unbounded means you don't know how many different values there's going to be for that tag. Some examples of that might be like a randomly generated ID or user input where you don't know what the user is going to input into there, or timestamps. All of these things are going to explode your cardinality and you don't really need them in there. Put those in fields. You can still query by them. It just might make your query a little slower, but it's going to make your overall performance a lot better. Now I want to talk a little bit about the Flux language. Now I'm not going to try and teach you the language here because my teammate Anais has a whole session on becoming a Flux Pro that you can also watch, and she's going to cover this much more in depth. But I want to talk about a few of the things that people tend to stumble on when they first start learning the Flux language. First thing to think about is that Flux is a function-based processing language. Almost everything that you're going to do in Flux is going to take the form of a function. And functions take what we call a stream of tables. Each function is going to get a stream of tables in, and most of them are going to return a string of tables out. And you use these to build a pipeline where the data in those tables gets streamed from one function to the next, filtering it down, massaging it, changing it to whatever you need it to be. And then we have aggregate functions like min, mean, max, and it's important to remember that those are happening per table. So if you have a stream of multiple tables, that aggregate function is going to be run once per table. That's another thing that tends to throw people off. And at the end of your Flux script, whatever your Flux query ends as, that's going to be used as the return value for your script itself. Now, I talked a little bit about table streams, and this is kind of what they look like. And here's another thing that tends to trip people up, especially if they're coming from like a relational database. When you query data out of Flux, you're not going to get a row with field 1, field 2, field 3 in that row, and then another row with field 1, field 2, field 3 again. Instead, what you're going to get is you're going to get every value of field 1 that there is in your database for your query, and then after that, you're going to get every value of field 2, and then every value of field 3. As a table stream like this, going through those functions, you need to think about, I'm processing all of one specific field at a time before I move on to the next one. Now, if you're coming from InfluxQL or a SQL database, this might sound more complicated, but it's really just the same things you're doing in a query statement, just reorganized a little bit. So you've got the same elements of saying what data you want, where you want it from, how you want to filter it, and how you want to group it. It's just done as a flow of information going through a pipeline instead of being a statement. And in fact, we use what we call the pipe forward operator between our functions to indicate that it is a pipeline that your data is going through from one function to another. So everything that you can do in InfluxQL, you can still do in Flux, plus a whole lot more. One example of things you can do in Flux that you can't in InfluxQL is you could orchestrate multiple queries at a time and weave them together. So not only can you just query the data out of the database and return it as part of your Flux script, you can save those queries as variables in Flux. And you can have multiple queries and multiple variables, and then you can do things with those together, like joining them or using one and a map on the other to manipulate it. There's a whole lot more that you can do. You can build more complex queries, you can perform more complex operations than you can in InfluxQL, and that saves you from having to do all of that in your own application's code. You can just run that all on the server. Another really cool option that Flux opens up is that we can start bringing in data from outside InfluxDB itself. One example is the SQL package. You can use this to connect to a relational database outside of InfluxDB itself, run a SQL query against that database, and get the data back into your Flux environment. Then you can have another Flux query that's querying your time series data, and then join both of those things together. A really nice opportunity that this opens up is storing metadata in a relational database where it makes more sense, but pulling that in as part of your Flux query and binding that to your time series data when you're querying that time series data. So if you have just like a country code as a tag in your time series data, but you've got a database table that maps the code to the country name and other country information, you can pull that in and bind that to your time series data and then use that in the final result of your query. In addition to SQL, you can also do this with CSV data or with an array where you just have some static information inside of your script. Another thing that Flux offers is what we call pushdown patterns. And pushdown patterns are a way to take parts of your Flux query and run it at a much lower level than it would normally run, down at the storage level where your data is actually saved. And by doing this, we avoid reading data off of that level and up into the server's memory before we start doing the operations on it. This makes the query a lot faster and a lot more performant for you. An example of a typical pushdown pattern is something you've probably seen before. It starts with querying from a bucket, giving it a range, and then doing some filters on it. If those filters are part of your series key, like your measurement or your tags, that's already separated out at the storage layer. So the Flux query engine can push those parts of your query down to the storage layer, and now it's only going to read the bits that match your query instead of loading everything up into memory and then filtering it from there. You can also perform windowing and certain aggregations down at that storage layer also. So there's a lot of things that you can do that'll make that query a lot faster. And then once you have just the data you want, then you can perform heavier operations like regrouping or running a map or a pivot on that data. So there's a whole lot more information that you can find on this online, but this is a really powerful pattern for you to learn to improve your Flux query performance. So here are some things to consider as you're learning Flux. First of all, learn to start thinking in columns instead of rows. If you're coming from a relational database background, this is going to be especially hard for you because you've spent years thinking about data in terms of one row at a time. And that's one of the biggest difficulties people have as they start learning Flux and InfluxDB. So keep reminding yourself, think in columns, not rows. As you're building more complex queries, remember that you can save those queries as a variable in your Flux script. And then you can reuse that variable over and over and over again in your script. So if you want to have maybe two different aggregations on two different fields, you can save the base query as a variable and then use it to perform one aggregation on one field and then another aggregation on another field. And when you do that, you can use the yield command to send multiple sets of data back as a result of your query, even if it's just halfway through your script. As you're learning Flux, play around with the Data Explorer. It's a great way to try it out. You can start off with the query builder, build your basic query by just selecting things from the drop-down menus, then click that script editor button and it'll show you the query that it's built. And from there you can start building on it and experimenting. Use the functions in the right-hand side and it'll inject that in there and tell you what properties. It's a really great playground for you to start learning Flux, especially when you're new. And lastly, remember those pushdown patterns and try to follow those whenever possible. That's really going to speed up your query. All right, now I want to talk about what you can do with the data once it's in there that's going to be useful to you. First, I want to talk a little bit about running tasks in the background. Now, Vinay and Balaji have done a lot more on this topic in InfluxDays than I'm going to cover here, so I really encourage you to go watch their sessions. Tasks are written in Flux, and they're going to be executed by InfluxDB itself. So InfluxDB is going to take care of the scheduling of these tasks. It's going to provide the execution environment for them, so you don't need a separate system to make sure they're being executed. You don't need a separate environment for those to run in. It's all built into the database now. And tasks can be used to do all kinds of things. They can read data, they can transform your data, they can write data back into another bucket, or they can alert you when something's gone like beyond a certain threshold in your data. A really common task that people use is what we call a downsampling task. And what a downsampling task does is it takes really high frequency, very specific data that you're getting close to the source, that you care about for a short amount of time, but not a long amount of time. And it lets you save an aggregate of that data for a longer period. So say you've got an IoT device and it's collecting data every microsecond. Now you might care about that microsecond specific data when you're near the device, but you're probably not going to care about it for a long time. So you create one bucket with a short retention policy, and you put that data in there, and it's collecting it, and you can monitor it at that frequency. But then when you want to save that longer term, you can run a downsampling task that will take thousands of measurements, turn it into an average of just one value for that minute or that hour, and save that in another bucket. So that's downsampling. That'll save you a lot of storage space. That will also make querying that older data a lot faster as well. You can also use tasks to perform alerting on that data. And we've got a whole interface in our graphical interface for building checks and notifications. And these are going to build tasks in the background for you. A check is going to perform the query of the data, check the thresholds that you set, and set a value of OK, warning, or critical based on whether it's crossed one of those thresholds or not. And then the notification task is going to look at those statuses and decide, OK, based on what this user's told me, I need to send an alert out when the data crossed this threshold. And you can do things like PagerDuty, you can send Slack notifications, you could even send just a raw HTTP response somewhere if you have a webhook or another service that you can connect that up to. And again, those are all running tasks in the background. You don't have to worry about scheduling those at all. So when you're using tasks and alerts, here are some things to keep in mind that are going to help you avoid some common mistakes. First of all, if you have a bunch of tasks, stagger their times using that offset field when you create them. If you have 10 tasks and you set them all to run every hour, what you don't want is all of them to try and start on the first minute of the hour. So you can have one start on the first minute, have another one start on the 10th minute, another one at 20 minutes, and so on, so that you're not performing all of your compute all at once and then sitting idle for the rest of the hour. Another thing that you can use in tasks, we have a tasks package in Flux, and it can provide you the last successful runtime for that. So if you're processing data for like downsampling, instead of saying, I always want to look at the last hour, oftentimes what you really want is I want to look at all the data from the last time I ran until now. So if something happened during the previous run and the task wasn't able to complete, maybe it's trying to use an external resource and that external resource wasn't available. Well, the next time it runs, you don't want to lose any of that data that it couldn't process the previous time. So that last success time lets you query starting at that point, moving forward, and that way you don't lose any data. When you set up checks and notifications, be aware that they have their own schedules. So you can have the check on one schedule and the notifications on another. And it's very common to have them both run at the same intervals and the same times. But that can lead to race conditions, where the notification is checking the current status as the check is still busy writing that current status. So you'll want to offset that notification check to make sure that the check itself has had time to write the data before it starts to see what that status was. And when you make a notification rule, typically you only want to be notified when things are getting worse, not when things are getting better. So you can say things like, whenever I'm in the warning state, send me this notification. But what you really want is if you go from OK to warning to get the notification. If you're already at critical and you're coming down, usually that means things are going well and you don't need additional alerts at that point. And finally, if you have a complex need when you're setting up your alerting rules, you need to do some extra calculations or something like that, you can always do that just in a task. You don't need to use the UI to build those alerts. You can just create a task to do it, perform whatever you need to do, and then end it by handing it off to one of those notification endpoints. Now, the last thing I want to talk about is actually fairly new for us, and it's something that we call edge data replication. Now, for a long time, people have been running InfluxDB on an edge gateway or close to their sensors, in addition to maybe having it up in the cloud somewhere too. But there wasn't an easy way for them to get data from one to the other. Edge data replication takes care of that problem. It lets you connect multiple instances that you have running on the edge, close to your devices or the source of your data, back up to a centralized location like InfluxDB Cloud. And it does all of this using the same kind of APIs and security that we offer for anything else that's writing to the cloud. So you can have a token that gives access just to write data to a bucket, not to read data from the cloud, not to write to other places in the cloud, but just one place. And what this offers you is a way to automatically set up data replication without having to write code, again, without having to have a separate environment or a separate tool that's going to query data out of InfluxDB and push it up. All of that's built in now. You don't have to do anything additional. You don't have to run anything additional. And it's also durable. So it's made to expect interruptions in its ability to synchronize data and not lose anything. So if you have a network outage between your cloud and your devices, it's going to keep collecting that data locally on the edge. And when that connection comes back up, it can restore that data to the cloud and not lose a beat. And it's flexible too. You can send data to multiple upstream sources. You can have multiple downstream sources feeding into the same one. You could even stack edges on edges, feeding data up from one to the other up until you get to that centralized cloud. So there's a lot you can do with it, and it's really simple to do. Setting up edge data replication is just a two-step process. The first thing you do is you tell your edge instance what remote you want to send that to, and that's just the URL of your host, your organization, and your authentication token so that it knows how to connect to that upstream database and to be able to send data there. Then you can set up replications for that remote. And a replication is where you specify which bucket you want to use as your source and which bucket in the cloud you want to use as your destination. And the reason these are separate is because a lot of times you want to have different buckets on the local side sending to different buckets on the remote side, but they're all using the same authentication and the same source. So you create your remote once, and then you can create multiple replications for whichever of your data that you want. Here are just a few tricks to get a better kind of edge architecture going. First, when you set up this replication, combine it with one of those downsampling tasks we discussed earlier. Chances are you don't want microsecond data in the cloud. That's a lot of data, that's a lot of network bandwidth, that's going to end up costing you money. So instead, use one of those downsampling tasks. Aggregate the data locally into a separate bucket, and then sync that bucket up to your cloud instead. You still have the level of information that you care about in the cloud, but without all of the resource usage and without all of the cost. Plus, when you're doing that, you can enrich the data on the edge. So chances are your sensors know about themselves, but they don't know about their edge. They don't know their location or what factory they're in or what building they're in. So when you're doing that downsampling task, you can additionally inject new data into that stream as it's going to that downsampled bucket to put in things like your edge location or ID. That way, when that gets replicated up into the cloud, along with information from other edges, people who are looking at that data in the cloud can separate yours from other people's. And then, like I said, you can stack multiple of these one on top of the other. So you can have one instance that's maybe monitoring an entire floor of a building. And all of that data, along with data from all the other floors, gets replicated up to another instance that's monitoring the building as a whole. So downsample the data a little bit, gather all the floors together, now you can monitor the whole building. But if you have multiple buildings, maybe that one is itself replicating up to another cloud instance where other buildings are replicating their data up. So now you can get a high-level view, a middle-level view, or a low-level view, depending on where you're at and what kind of data you care about. All right, I want to leave you with just a few things that you can do to continue your learning and to continue your path to becoming an InfluxDB Pro. First of all, go watch my teammate Anais's talk on becoming a Flux Pro. That's the companion to this talk where she's going to dive a lot more into learning Flux, the things that you can do, and the power that's available to you there. It's going to be a great talk. Go watch it. Also, go to InfluxDB University and take some of our online training there. Most of this talk is coming from the InfluxDB Essentials course that we built for this, but it'll go into a lot more depth. There's a lot more that it covers than I can do in 20 minutes. So go watch that. There's other courses on Telegraph and Flux. We have everything from beginning level material all the way up through advanced, so no matter where you are in your journey, we've got some content for you. Plus, when you complete one of these courses, you can get a badge on your LinkedIn profile to show off to your peers and potential future employers that you've mastered these skills. Also, check out our Time to Awesome book. That's at awesome.influxdata.com. This was written by my teammates Rick Spencer and Anais, who I was mentioning earlier. This book dives a lot more into things like the data schemas, proper ways to set up your schema for optimal performance. It'll cover more about columnar data versus row-based data you might be familiar with, and it'll talk more about table streams and how they're coming out of the database and how you can work with them better. And finally, here's just some resources for you. Some of the things I covered, like the InfluxDB University, links to joining our cloud account, plus our community. We have a community forums and a community Slack where myself and the rest of the DevRel team all like to hang out, and we'd like to talk to you there. Thank you, everyone. Now, stick around for more sessions and enjoy the rest of InfluxDays.